Alright, time for another draftphysics.com, debatephysics.com also, where there are a bunch of 5-minute videos on this subject of kinetic energy versus momentum. And this will be something like that. Maybe I'll talk a little longer than 5 minutes though. We'll see what it takes. So the subject is the ballistic pendulum, and how, like many of these other experiments, it's just kind of a dramatic proof of the paradox, plainly, the illogic of the kinetic energy theory, in the sense that we are told something has a kinetic energy, all right, and then when in the ballistic pendulum case it's measured, so let's just say this had a kinetic energy of 20,000 joules, the bullet. Then when it goes into the pendulum, it's going to reveal its momentum, because I'm going to be able to calculate the velocity of this bullet by using the momentum of this heavy, all right, massive pendulum. It's going to move a little bit when the bullet penetrates into a clay substance, any kind of retarding substance that causes the bullet to slow down, a gel or something. And the momentum will be transferred, some percentage of it. Obviously, you lose some momentum to the path the bullet takes and to the displacement that will be, and some amount of heat. But the argument is what you will not find is any collection of any amount of this. So Professor Lewin is going to tell you that you're going to lose 97, I think, percent. 97% of the kinetic energy will be lost, yet, okay, you will conserve 97% of the momentum. So you conserve 90% of the momentum, you lose 90%, 97% of the kinetic energy. So you can use the movement to measure the velocity of the bullet, because the momentum is fundamentally conserved, the substance of the momentum is conserved, yet, okay, you're supposed to believe that you created a whole bunch of activity, motion inside the clay that amounts to 97% of its energy, but you didn't use any momentum to do all that heating. So you did all that heating and all that disturbing without using any momentum. So this is very similar to the simple experiment where you add weight to a 5 mass going 10 velocity, and you add another 5 mass to it, and you end up with a 10 mass going a 5 velocity. And we're supposed to believe, that you perfectly conserved all of the momentum, yet you lost half the kinetic energy, and you lost it in some sort of form where it leaked out of the system. Yet those things leaking out of the system, those pieces flying off, or that heat, somehow didn't use any momentum. No momentum, zero momentum used. So it's like saying you could hit the bowling pin and the bowling ball wouldn't lose any energy, wouldn't lose any speed. It don't work that way, kind of obviously. So I'll let him say this and validate the point that you don't think you need to explain, and you think it's so obviously true that you can lose 97% of the kinetic energy and conserve 97% of the momentum, and everything's just fine. That makes sense to you, that you can create a substantial amount of heat without using any momentum. And they never measure the heat, so let's just understand. It's just stated as a throwaway line that, oh yes, it did a bunch of heat and deformation. It's just said. It's never, ever, ever demonstrated to be true. Doesn't work. Everything's frozen. That's why it doesn't work. Yeah, so that's a bummer. Alright, hopefully continuing. Yeah, hopefully. All right, so Professor Lewin has shot the gun, measured the bullet. You can see the gun over here. Okay. Within 15%, measured the velocity of the bullet based on conservation of momentum, basically. So, and now this is what he's going to say.
We had kinetic energy in the bullet before the bullet hit the block, and you can calculate how much that is, because you know the speed now, and you know the mass, 1/2 mv squared. You can also calculate how much kinetic energy there is when this bullet is absorbed in here. That's very easy. That's 1/2 times the total mass, m plus m, times v prime squared.
Well, we know the m plus m is irrelevant because the bullet's a tiny percentage, just an absolute infinitesimal percentage of the absolute weight of this ballistic pendulum. So the pendulum weighs 1,000 times more than the bullet. That's why we have such a dramatic loss in the kinetic energy. It's purely statistical. It's a statistical fact that you're going to convert the momentum from the very small thing into the very big thing. And every single time you do that, you are going to lose energy. And the more dramatic the difference in the weights, the more dramatic the loss of kinetic energy. And it makes zero sense. I don't know why I have to even argue this with anybody who's reasonable. The fact that physics says so is just plain silly.
Which you also know now. And so you will see then, perhaps to your surprise, that if you compare the two, that 99.94%...
There, it's more than I said. I was giving them a benefit of the doubt. 99.47%. 99.9% of the kinetic energy is gone, disappeared. And he's going to say, well, it's heat, or, you know, but how could you make heat and conserve the momentum? How could you have 97% of the momentum conserved and then claim you lost 99% of the kinetic energy? It just can't make any sense to somebody who's being fair to the facts.
Of all available kinetic energy before the collision was destroyed and therefore was converted to heat. That happened, of course, the heat was produced in that block.
So that's all. He just says the heat was produced inside the block. Well, of course, we didn't measure it, because if we measured it, we'd find out it's way short of the 2,000, the 20,000 joules we said we started with. It's not going to be anywhere close. And of course, it can't be close because I conserve the momentum. I can't make it move and make heat. I can't do both those things. Heat can't be converted directly into movement in this case because the heat's going to be dissipated into the atmosphere. It's not being dissipated into motion of the ballistic pendulum. It is lost energy. It's lost momentum. So every bit of heat has to be accounted for as some loss of the momentum of the ballistic pendulum. The ballistic pendulum cannot do both things. It cannot heat water and bicycle to the drugstore, for example. It can't do two things. It can only, the energy can only be in one place. It's either in the motion or it's in the heat, but it can't be in both places. The momentum can't be in both places. Good enough. Fuck this.
That 18.
I mean, just disgusting that this guy sold out. I mean, it's bad enough that, he had to be censured off of MIT because he was flirting with his students, but to do this commercial crap like he's desperate for the $15. I mean, it's disgraceful. All right, anyway. Ugh, what an asshole. I'm sorry, but you're just a pathetic asshole. I mean, I remember in the past he made a mention about how, well, the commercials, there are too many commercials, so I talked to the company that paid me, and there shouldn't be so many, and there's even more now. Obviously, he just couldn't care less. He wants the damn paycheck. Ugh, disgusting. He has his house has a name. He calls his house a place, like it's Wonderland. He has a little sign out. Gibbigob Valley or something, some kind of bullshit. Jesus. Way out of control. Alright, anyway. So, look, I'll just go back. Don't want to make the video unnecessarily long for all the morons in science who can't tolerate too long a video. But clearly, look, the 10-ton train, 5-ton train thing is a perfect example. They've never tested it. They've never taken a 5-ton train going 10 miles an hour and a 10-ton train going 5 miles an hour, put them on a tug of war, and proved that the 5-ton train has twice the energy. They haven't done it by crashing them into each other and proving that the 5-ton train pushes into the 10-ton train. Never done anything to test any of this stuff. And then this example, again, is so outrageous. 99.74, he said, percent of the kinetic energy is destroyed. He even said the word destroyed. I mean, he said heat, but then he says heat, but we know it's not there. We know this giant joule number isn't in the heat. There's not enough heat to justify the statement. And we know that the ballistic pendulum actually did move. The very heavy thing did move, so most of the momentum in the bullet did go to moving the big heavy thing. Momentum's conserved. You can't do work and conserve momentum. I guess, do I have to say that? Is that really what we're going to argue about? That you're going to tell me you're a reasonable person, you care about science, you're a physicist, for example, and you're going to really argue that you can do work, okay, and conserve the momentum? That is, you can do work on the environment, and yet you'll still have the same momentum? You can knock down bowling pins, but you don't have to lose any momentum in your bowling ball. Is you really going to argue that and defend that? This is decisive, critical evidence that this is a nonsense theorem. And it's just plain obnoxious of you people that I have to spend years arguing this. It's disgusting. It's a disgusting state of human intelligence that reasonable people, instead of making a rational argument explaining how this nonsense could possibly be true, and why you have absolutely zero evidence, in the sense you've never tested the heat in this example, you never tested the heat in this example, you never test any of it, and you're going to tell me you know it's true. There's nothing else to say. This is such bullshit.